Before we start the video, a large thank you to Payne G, Sanji, Mikhail, and Jacob for their support on Patreon. I hope you guys enjoy the video. And as always, an immense thank you to Halo Burner and Ryan Bellin for their immense support to the channel this month on Patreon. It is sincerely and greatly appreciated, gentlemen, and I hope you enjoy the video. Hello everybody, so I'm in my project here, and you can see I have a view of what we're going to set up. So I can click this button here, and I can toggle the light bake mode, which is basically going to enable every single renderer across all of my scenes, like so. And then I have a button called toggle game mode, which is going to default them back to being off and disable every root game object. Now as I move through the world, it's going to enable root game objects over time and then enable the renderers. This is all going to be done automatically for you, and if you make edits to your scene, we're going to set it up so it will automatically add these renderers and objects to your scene list when you save, so you don't need to constantly go back and you make a bunch of changes to the scene and you forget to drag them in. But you can see here we also have some other helpful buttons for enabling the root objects and renderers and disabling them, and we're going to set that up by basically making some scripts to modify how the inspector looks for our managers. So first, let's start by creating a new script, and I'm back in the Elden Ring Unity project right now. We're going to call this World Location Renderer Manager. And what this is going to do is it's basically going to house all the renderers and root game objects for each individual scene. And then we can enable or disable them as we please. So let's start by putting in our namespace and erasing start and update functionality as is per tradition. Now, the game object thing is a bit of a bonus. Basically, if you want to save some memory also, we can start with all the root objects disabled and enable them over time. You don't need to do that, but it definitely does help with memory, so I'm going to showcase how to do it anyway. If you have a very comprehensive and complex project, it helps to save memory wherever you can. So let's start by making a header for the scene ID, hide an inspector, public int renderer scene ID. This is just going to be the scene ID that this game object is placed in, because each scene will have their own renderer manager. Then I'm going to make a header for root game objects, make a public list of game objects. Need to say using system.collections for this. .generic. Okay, so we have that. Let's make a public list for game object, and I'm going to call this root game objects, or root objects rather. And we're going to make that a new list of game objects. So basically too, if you have any awake or start calls, then enabling all your game objects over time will stop the throttle of all your starts and awakes being called at once. In general, it's a really good idea to make sure you don't have too many unawake and start calls on things in your additive scenes, but sometimes you can't help that. Let's also make a list of mesh renderers called mesh renderers in scene. And then we're going to make a private coroutine here. We're going to call this toggle all mesh renderers. And we're going to call this toggle all mesh renderers coroutine actually, because we're going to have a function that toggles all the mesh renders. So let's make a awake call here and say the renderer scene ID is equal to gameObject.scene.buildIndex. And what this does is just basically gets the scene this game object is in and then gets its build index, which is very useful for what we're going to do. Then right below this, we're going to call upon our world subscene manager, which I'm going to rename this video because that name is just, it should be world location manager. And we're going to say add location renderer. I'm going to say this, add location render manager to list. And then we're going to pass this. Now this doesn't exist yet, so comment it out. But basically our world location manager is going to have a render manager for every scene that's loaded in. And from there we can enable and disable the renderers as we need be. But again, that doesn't exist yet. We're getting ahead of ourselves, so comment it out. Now on start, we're going to say when a scene is loaded into the world, you may optionally enable the game objects over time to help prevent possible stutters. So we are going to do this. If a loading screen is present, however, you can ignore the overtime call and enable them all instantly. So the first time you load in the game is going to be a loading screen, but as you move through the world, there will not be a loading screen. So both of these do have value. We can start by checking if the player UI manager.instance.player UI loading screen manager.loading screen is active. Otherwise, we do the other call. So if the loading screen is active, basically enable them all instantly. If the loading screen is not active and you're moving through your world, you might want to enable them over time. And normally you might not have more than 15 or 20 root objects. So what I do is enable one per frame. You may need to change this depending on how many root objects you have. You may need to make a calculation for it and make sure they're all enabled by X time. But generally speaking, I find one per frame to be fine for me. So I'm going to do that in this video. Public void find all root objects. Let's make this function first. And we're going to say root game objects is equal to a new list for game object. So the list we have up there, we're going to initialize it as a new list here. And then we're going to say game object array root objects in scene, we get every root object in the scene by saying is equal to GameObject.scene.getRootGameObjects. That's a very handy call for what we're doing. Next, we're going to do a for loop, and we're going to say, and we're going to iterate through the root game objects in the scene, the array we just made. And we're going to say if root game objects in scene, let me just copy and paste this up here so we can go through it properly. There we go. Dot length. All right. So if root game objects in scene I is equal to the game object of this object, continue, don't add it to the list. We do not want to add the render manager to the list of root objects because this object is always going to be active. It's never going to change. Then we're going to say if root game objects dot contains root objects in scene I, also continue. We don't want to add an entry more than once. And then we're going to say root game objects dot add root game objects in scene I. Okay, that's basically it for finding all the objects. Next, let's make a public void for toggling the root objects, and we're going to have a status for enabled or disabled. Now we're going to do a for loop again. We're going to iterate through all of the root game objects we have from our list. So obviously first we're going to find all the roots somehow, but we'll get to that later, don't worry. This assumes we have them all located. And then we're going to say if root game objects I is equal to null, for some reason continue. It shouldn't be, but if it is, continue. Then we're going to say root game objects I dot set active, and then we pass the status. And that's it. Now we're going to make one for over time because, as we said, we can put this right here, enable all game objects. We can say toggle root objects, we can pass true. But if you're moving through the world and you have a very, very complex scene, maybe you don't want to enable them all at one time because it might cause a hiccup of sorts. Let's come up here and say using system.collections because we're going to use a coroutine for this. Now what we're going to do is simply say private IEnumerator. Then we're going to say enable game objects, or rather enable root game objects if you prefer, over time. And now we're going to open up some curly brackets and we're going to basically take this for loop here and paste this in here, but instead of status we're going to say true. And then we're going to wait until the end of the frame to continue by saying yield return new wait for end of frame. Now, like I said, if there's too many root game objects, you might want to make some kind of calculation here to determine how long you should wait. But I'm going to use this because generally speaking, it's been fine, and I have a pretty large world and lots of objects. So I'm going to say on start now, start coroutine, enable game objects over time. You don't need to keep this as a variable because it's only going to fire one time. If the scene gets unloaded, it stops anyway. All right, that's cool. Let's save that. That's basically all we need in terms of our game objects. Now we need to handle the renders. So I'm going to make a comment up here saying root game objects, and then right below this, I will make a comment saying renders. Cool. So we can do the same thing. We just got to basically find renderers now instead of root game objects. It is going to be a little bit different because we don't have a function that just gets us all the renderers in the scene like we do for game objects, but we can make that work using some logic. So find all mesh renders. We're going to say mesh renderer array. And then we can kind of like go off the logic up here a bit lightly with some minor alterations. So we can say mesh renderers in scene is equal to find objects by type. And obviously this is a heavy call that you will never call during runtime, but we're never going to call this during runtime. It's going to be done while we're actually building the world, so it doesn't matter. This will never get called in actual gameplay. So we're going to say find objects include, find objects inactive, include, and find objects sort mode none. Okay. Now, we have all of the mesh renders, and this actually isn't in the scene. I'm going to change his name in a moment. It's a bit misleading. This is actually all mesh renders you have in all scenes because find objects by type is going to find everything. So the mesh renders we have up here, I'm just going to rename this to mesh renderers so it matches the name of root game objects. And I'm going to say mesh renderers is equal to a new list, similar to how we made a new list of our game objects and cleared it out. And right below here, what we're going to do is do a for loop, and we're going to iterate through every mesh renderer we found. So we're going to say mesh renderers in scene.length, and again, that shouldn't be in scene. I'm going to change that momentarily because that name is slightly misleading. We're going to say if mesh renderers in scene I dot game object dot scene does not equal the game object scene that this is in, continue, because we know that render is not in our scene. As such, we should not mess with it. And then we're going to say if the mesh renderers actually already contains this specific mesh renderer that we're looking for, then we're going to continue because we don't want to add it to the list. Otherwise, we're going to say mesh renderers.add mesh renderers in scene I. Let's change that to just all mesh renderers instead of mesh renderers in scene, because again, that name is misleading. So basically, if we don't already have it in our list, we're going to add it. And if it doesn't exist in the scene that this game object exists, so if it's not in our scene, we're going to ignore it. All right, cool. We have a way of finding all of our mesh renderers. Now we want to toggle them. So let's just do a toggle mesh renderers, and we're going to have this require a status. And this one's going to be identical to our root game objects functionality. We're just going to do a for loop, and we're going to set it to the activity of the status. So I'm going to copy a for loop here, and I'm going to copy the name mesh renderers. We're going to iterate through all of our mesh renderers that we found in the function above. We have to use .count because it's a list instead of .length because it's not an array. And then we are going to say if mesh renderers I is equal to null, simply continue. Otherwise, we're going to say mesh renderers I enabled is equal to status, which we don't have. So let's go ahead and put that here and copy it from the root objects and paste it here, equal to status. Okay, cool. Now we have a find and we have a toggle. What about a enable over time, or rather a toggle over time? Because if you want to disable them too over time, then that can be an option. Now, generally speaking, you're going to have a lot more mesh renderers than you're going to have root game objects, probably in the thousands. So you're probably going to want to come up with a specific time based on the amount of renderers using a calculation you're seeing to enable these at. But I'll just write the logic here anyway if you want to use it. So I'm going to say if toggle all renderers coroutine is not equal null, stop coroutine, toggle all mesh renderers coroutine. Otherwise, toggle all mesh renderers coroutine equals start coroutine. And then we're going to say toggle all mesh renderers over time coroutine, which doesn't exist yet. So let's make that. Now, why would you want the ability to toggle these over time on or off? Well, if I leave a certain portion of the map that you're in, or rather you leave me and go to a different portion of the map, you want to disable the renderers that I see over time. You might not want to disable them all instantaneously because that might contribute to a hiccup. So here is an option to do that. I'm just going to paste this logic for the for loop here. And instead of searching through root game objects, we're going to search through the mesh renderers. And then we're going to search through again to see if the mesh renderers is null. And then otherwise, we're going to say mesh renderers I enabled status. And we're going to make this require status, of course. So we're going to say enable is equal to, and let's paste the status up here. So again, you don't want to do wait for end of frame for this because you're going to see them pop in almost certainly, unless you have a very small scene. So I'm just going to, this is where you would want to say wait for time or wait for wherever, and you want to maybe calculate that yourself. Let's make this also require status, of course. Or you could run it like with update maybe and do a bunch over the update. But I'm just going to remove this for now and put this yield wait for end of frame out of the for loop. And then you can decide how you want to handle that in there. So this is basically going to wait a single frame and then do them all instantly right now. But there's the logic in case you want to use it. Okay, now I'm going to save this. And I'm going to open up the World Scene Manager. And generally speaking, in my testing, enabling and disabling the renderers instantly has not been of impactful performance to me, but the game objects can be for sure if you have a very dense scene. But you can optimize where you need to. So let's go over to the World Location Renderer Manager. I've now changed the name from World Subscene Manager to World Location Manager. And that feels a lot better to me. Now let's make this function for adding the World Render Manager to a list. So again, we're over here back on the World Location Manager, formerly the World Subscene Manager. We're going to make that function that we just had in the commented code called add location render manager to list. We're going to make it require a world location render manager. That's the new script we just made that handles getting all the locations, game objects, and renders. And then what we're going to do is make a list up top to actually support these. So what are we keeping a list for? Well, as the script is called the world location manager, it handles loading and unloading locations in the world. It's also going to handle basically when you're going to toggle or check for renderers that you need. So again, if I'm in area 3 and you're in area 1, you don't need the renderers I have in my scene loaded. There's just no point or no purpose for it. So for that reason, we're going to disable them. And the inverse is also true. If you're in another area for me, I don't need your renders loaded. So this is where this is going to come into play. We're going to just basically get all the world location renders and toggle them as we, the local player, need them. So we're going to just do a for loop up here now and check the list we just made for our world location renderers, which I've called world location renderers up top. And we're going to say if world location renders I is equal to null, continue. Or, sorry, not continue, we're going to remove it. We're going to say world location renders dot remove at I. This is because the scenes are always changing. They're always loading and unloading, so you're always going to have this list changing up. So just remove any null entries every time you add a new one. And then we're going to say if the world location renders does not contain the world location render manager we are passing, then we're going to add it to that list. So basically the TLDR is this list is going to be a list of all active scenes and their renderer managers. And you always check for null, as the world is always going to be loading and unloading, meaning this list is constantly going to change. Entries will constantly be added and removed, as the world changes. So under load area based on area currently in, you can see here we have a check for unrequired scenes call. Well, we're also going to make a check for our renderers that we need. So we can say world scene manager.instance check for required renderers. And this doesn't exist yet. So let's go ahead and make that right now. If I jump to the world scene manager here, right under check for unrequired scenes, I'm going to put this just because I feel like it belongs there for neatness sake. The name is very similar, kind of in the same call. So what we're going to do here is say if world location manager.instance is equal to null, simply return. This would indicate that you're probably at the main menu, so this doesn't need to be called. And now we're going to make a coroutine for this, and I'm just going to make I didn't make headers here, I made comments, okay? We're going to do a comment for scene renderers. I'm going to say private coroutine, and I'm going to call this, what am I going to call this? I'm going to call this required renderers coroutine. I think that's a pretty clear name. I think that's what I called it in F. I can't remember, to be sure. If required renderers coroutine does not equal null, we're going to simply say stop coroutine, required renderers coroutine. We're doing this because you could get this call multiple times across a few frames while still going, so stop it and restart it basically with the updated information. Then we're going to say world location scene set rather. Location is equal to player UI manager.instance.local player. And then we can say dot location, or I think it's called area currently in. Yeah, I might rename that too. But we're just getting the location that your local player is currently in, basically. And then we're going to say if location does not equal null, we want to actually start a coroutine. And the coroutine is going to be required scenes coroutine is equal to start coroutine. And we're going to call this check for required renderers, or if you want to, required scene renderers coroutine. And again, this doesn't exist yet. We're going to pass location. And now I am going to make this right below here. And I'm just going to move the scene ID fetch thing up here, just right above here, so I can put the other function right below that. There we go. All right. Now I am going to say private enumerator, and we're going to say check for required renderers coroutine, just as I wrote it up there. And of course, we make this require a world location scene set. I definitely should have called that world location for short. Maybe I will rename it later. But we will call that location, and then we're going to make a list of strings. And this is going to be the scenes that you require from this location. So we'll say scenes relevant to the location, because this is basically going to be the list of every scene we want to keep the renderers active in. And then we're going to say location dot get required scene IDs for world location. And then we need also the build indexes. So we're going to say list int, and we're going to say, what am I going to call this? We'll call this scene build indexes. This is equal to a new list of int. And then right below that, we're going to do a for loop here, and we're going to iterate through the scenes relevant to the location we're currently in. And we should check to see if this list is actually not null. So I'll do that in a moment too, just in case it doesn't generate one somehow. But we're going to iterate through using a for loop. So we'll say scenes relevant to the location you're currently in .count. Then we're going to say scene build indexes .add. We're going to say get build index from scene ID. And we're going to pass the scenes relevant to location currently in I. Now, this doesn't exist yet, but this is going to be a very simple function. I'm going to do that if statement here first before we write that. So we're going to say if scenes relevant to location currently in does not equal null, then do this for loop. And now this function is just going to be a very quick function to basically turn our string into a build index. So we can say public int get build index from scene ID, because scene IDs have a name and a build index, but in this specific case, we want the build index. There we go. We can pass a string for scene ID. Then we say int build index is equal to, and we can say scene utility dot get build index. Whoops, oh my goodness, I can't type right now. Dot get build index by scene path. We pass our scene ID, we say return build index. Very handy also. So then we're going to say for loop here right below that. And now we're going to iterate through our world location manager dot instance. And then we're going to grab our world location renderers dot count. And of course we want to check for null entries because again, the constant loading unloading, it might be null. So we're going to say if world location renderers I is equal to null, simply continue. And then after we check for null, what we're going to do is say if scene build indexes, so the list of ints we have up there for all of our scenes, contains the world location manager world location renderers I dot render scene ID. So if the scene build indexes contains this ID, then we know it's good. Otherwise, we know we don't need it. So what are we going to say here? We're going to say if player UI manager dot instance dot player UI loading screen manager is active. So if you are on a loading screen, which only happens initially when you come into the game, then we're going to toggle them all instantly, right? Otherwise, we're going to put them all in over time. So if loading screen is active, else, and we can copy and paste this right down here like that too, because this top side is going to enable them, and the bottom side is going to disable them. So we're going to say world location manager, world location renders I, toggle mesh render is true. And then again, if you want to do it over time as well, you can have your function here for toggling them over time. But again, just be mindful of how you calculate that because there's going to be a lot of renders, so you don't want to take too long to enable them all. And then the inverse is true down here, just copy and paste, but change true to false. And this is basically going to be, oh, right down here too, let's just say yield return null. This is basically going to be how we determine, or rather how we are going to enable the renderers as we move through the world. So we have a way to enable and disable the renderers, and we have a way to enable and disable the root game objects over time as the scene activates. But right now we have no way of getting the game objects and the renderers automatically. So in the next video, we're going to make some scripts to actually modify the inspector, and you're going to be able to click a few buttons and then it will toggle and disable all of the renderers and game objects in your scene as required. So for example, when you're baking lighting, you want to have them all enabled. And when you're actually going into a live game, you want to disable them all. And then every time you modify your scene and add new things to the world and save it, we're also going to make it automatically add to your list. So you won't have to remember to actually add them yourself manually. I told myself in the beginning, it's not a big deal, I can add them manually. And then the amount of times I went into the world only to realize I forgot to add renders or game objects to a list, it happened too much. So automating it is a much safer alternative. All right, guys, thank you very much for joining me. As always, an immense thank you to my patrons. You guys keep my lights on. Thank you to the people who take the time to leave a like and comment in the video and share it via word of mouth. The series is alive and well because of all of you. I hope you all have a very lovely weekend, and I will see you guys next week, unless you're also watching the second series, in which case I will see you tomorrow.